Every chance I get, you can see one of my results in the background.
Yeah, what is that?
Okay, this is Gemini. It's a B-class star with emission lines. And the setup I've got a 2-inch square, 300 lines per millimeter grating that sits on the front of it. I get very high resolution of it, so you can clearly see the emission line.
Mhm.
And plus, you can see a lot of other weird things that are going on in these stars, indicating some sort of rotation or expansion of gases that you can't see with a star analyzer in the back of the telescope.
Mhm.
I've been doing, I've taken quite a few of these and I send them to the AAVSC and I use RSpec. I'm having more success with RSpec than I am with ISIS putting it all together.
Yeah, that's not unusual to hear. ISIS is, for those of you who aren't familiar with it, is a wonderful program. By the way, if you want to see the background that Conrad's got, you can click on that view button again and select gallery, and it'll flip back to whoever's talking. You can go, or you can actually click on his image. I think you can select pin, click on the ellipsis on his image, and pin, and that will show it big. ISIS is an unbelievably powerful program that was written by Christian Bouil in France. Valerie, his close friend and partner, wrote VSpec. And the two of them are really amazing people. I got to meet them at a star party in southern France in 2011. Something with, as things open up, if you haven't heard me talk about it before, I'd encourage you to think about going to southern France sometime. You make it a fun trip. And the cool thing about it is that you can take your spouse or your partner. And the reason to do that is because you get points on the board when you take them to Provence, where there's all that lavender growing and wine and fresh croissants in the little village. And there's a lot of spectroscopy at the Spectra Star Party, which I think is in the beginning of August. Anyway, I met Valerie and Christian there, and they were also at the Las Cruces spectroscopy star party about 18 months ago, I think it was. Great people. And ISIS is really the go-to program for high-end scientific work. I, to be honest, have never been able to learn it. I sat through a workshop where they were teaching it at that workshop, at the workshop in Las Cruces. And I'm not sure anybody actually learned how to use it during that hour. Anyway, hold on a second. Somebody has sent me a message here. Not sure why, Horst, I'm not sure why you can't get in, what that link's about. Anyway, it looks like things have calmed down a little bit, so maybe we'll start. And we can keep things a little quiet. There's Ari from southeastern Brazil. Thank you for joining us, Ari. That's on the chat window. So I wanted to just show you some features. By the way, Conrad, not to cut you off, excuse me.
That's okay.
Conrad has done some really amazing. In fact, you have a website, Conrad. Do you want to put that into the chat so people could visit it?
I don't have a website. I've never put one together of my work.
I thought you had posted some that I saw.
Oh, no.
Anyway, thanks everybody for joining us. So what we'll do is Lauren will be joining us shortly, and also Tim Stone, who's in one of the little stamp panels you're seeing on the screen there, are both RSpec users, and they have some stuff just to show about what they're doing with the software, and we'll keep it real informal. We won't go that late. It's nice to see you all. We really, especially in light of the challenges of the last year, community becomes important. And I consider you all part of our RSpec family. And I'm always pleased to see people using RSpec and doing fun things. And as many of you know, I'll go out of my way to bring you more fun when I can, whether it's new features or answering questions or whatever. So what I'm going to do now is just go into my screen share here. Share my screen and then bring up this familiar screen. There it is. So there's one major feature in this release and some smaller ones. But this one is a pretty exciting one if it's something you'll use. You can see there's a new button up here And that brings up the screen called presentations. And what I'm going to do is just load a presentation, which will ship with the product. So you'll be able to start with this. I'm going to click on import presentation. And this in the RSpec folder under sample spectra, there are a couple of presentations. Now, we'll talk again in a minute about how to find these on your computer, but let's open this one. So there it is. So yeah, let me just hey Tim, I meant to make you a co-presenter. Just really messy management on my part. Let me get Tim set up here as a co-presenter so he can let people in and stuff like that. Co-host, I think it's called. More, make co-host. Okay, so you can let people in too.
Turn off that that holding room too.
Yeah, that I can do. I'm always a little nervous about doing that, but I suppose if we're not really looking at people's names, I don't know everybody's names either. That might not be a bad idea. I think probably everybody's here already. Okay, so this I call this presentations because it's not for doing a lot of data analysis with these extra profile lines here. I was going to call presentation manager, but I thought there's enough old people in our community like me who might remember there really was something called the presentation manager several decades ago on IBM computers in OS2, I think. So, yep. So these are again itemized over here on the legend. So as you hover over them in the legend, you can see in the main line, like other things, they get highlighted. And also if you click on them here, they get highlighted there, as well as if you click on them, the row that they're in the presentation screen also gets highlighted. I think you can have up to 20 of these. Yeah, 20. It seems like whenever I cap things at whatever number I choose, somebody comes along with a good reason I need to have more. And that's why, by the way, there are, how many now? 200? No, 145 or so, 143 labels. There's nobody who... Zoom meeting? Nobody can use all those labels. You know, I also meant to mute everybody, but I'm not doing many of these meetings anymore. I don't do a lot where I'm hosting. There, mute all. Okay, so if you want to talk, excuse me, if you do want to talk, feel free to unmute yourself. So there's not a lot to this screen except how to build it, how to actually use it. And what is this screen? Well, you saw from the name of the thing I opened, this is the OBIA Fine GKM stars. And I wanted to show you a page from Gray and Cordabi. Is that how you pronounce it? I should even have it here. Hold on, let me bring that up. It's supposed to already have it loaded, but again, there it is. Let's bring it over here. So there it is, Cordabi. This is one of the standard works, a very technical reference work. The first chapter or chapter or two are really the only ones which I read in detail because it just gets too detailed as you go in deeply. But here you can see the familiar drawing or image of the stars in temperature order with the hot stars at the top, and they're calling out the wavelengths. And then on the next page, they do it rectified, and I'll show you that example in a moment. The challenge with representing data like this is that the ADU, you know, your x-axis value or your y-axis intensity value may vary from spectrum to spectrum, given the, you know, the conditions in which it was captured and the equipment that you used. So over here are two tools that allow you to basically do the same thing that this does when you just have a reference and a main profile line up, and that is adjust their position. So for example, let me click on this light blue one. So that's a type A star. So once that's selected under scale, I can scale that, you know, just basically to adjust the spacing. And it's for a visual presentation. Again, if you stretch things, of course, you're changing the data. You know, these absorption features look more deeply. So that's why I call this a presentation screen. Now the other thing is on this screen is how to show you that. Oh yeah, same place under scale. Let me reset all. This is the way the data originally came in. And by the way, you can see the data came from the reference files in our software. And I'll show you how to build this screen in just a moment. But just the nature of the data is this type M star just had a wider range than these others. And it just looks terrible, right? That's where you'd select the scale tab, select the row that you want to adjust, and then you can just adjust things so that they overlap in a way that's more aesthetic and is easier to read. So the one other thing to show you, let's, of course I shut it down, so let me open it again. Under, in Gray and Corbali, you can see here just under 6,000 is the sodium D line. And it's not something we can typically see with just a grading, but I wanted to show you that line, which is right there, and show you something about labeling it. You'll notice, by the way, when I opened this presentation, all this appearance information automatically loaded, including all of these labels. If we scroll over, all of these labels here. So suppose I wanted to label that sodium D line. So I come to an empty label spot. You'll see just how much I've forgotten about the software I've written. And then there's the wavelength. And I'll put in NAD. There it is. And let's raise it up to here, you know, and adjust it a little bit. Okay, now I would think I'm done. The problem here is, watch what happens if I rescale this screen a little bit. Notice that's moved a little bit. The other the other labels are staying fine, but this one is moving all over the place. It's nowhere near where we want it to be. And that's because I anchored it on that red line there. We really want to anchor it on the blue line, and we can do that now. This is just part of the housekeeping of getting these labels to stay where you want them to be. So what you do here is you would click on the blue line where you want that label to be. And where was that? That is here.
Why do you want it on the blue line and not the red line? Missed that.
Because you want it, guys, good question. I'm not doing a great job of explaining this. You want to anchor it on the line adjacent to which you want them to stay anchored. In other words, let's see, here's another way to show you that. Suppose for some reason I want to move this blue line up. So I select it and I'm going to scale it or there it is, up. Notice these are all anchored on the blue line, but this isn't. That's anchored on this line down here. So in order to anchor these labels on the line where you want them to stay attached as scales change, I mean, I actually hadn't thought about this when I implemented it. And then I brought up the software in a smaller screen view, and none of my labels were close to the blue line anymore. They'd all drifted away. So, I mean, it's pretty intuitive. What you do is when you're anchoring your labels under wavelength, click on the line you want to be anchored to. So, oh, there's Lauren now. So now, if I hover my mouse over the word wavelength, it says it's anchored to profile 6, which is this one. It's not a lot. Again, you do it as if you just do it the way you do it intuitively, and that is just click on the line where you want the labels to be anchored, and then you can move them around. Then the standard stuff occurs. So here's the deal, though. I wanted to show you just for a moment. Welcome, Lauren. Just for a moment, I wanted to show you how to build this. Because there's some interesting things in that. So what I'm going to do is come up here to Tools and clear all rows like that. So this is how it would open in a new one, or if you closed it and reopened it with this button. And then all you do is drag .dat files in. So let's just go to RSpec Documents and go to our reference library. Now, it doesn't have to be the reference library. That's just some of the best data that I have. So now all I need to do is in the reference library in RSpec is just drag in the stars that I want to deal with. And so in this case, I'm just looking at my notes here. I tried to choose stars that were the same subtypes. So M3V, you just drag it in. So now we've got one star dragged in. And you just drag in the stars that you want to include. Let's just do one more so you get the gist of it. This is a type K star K3V. So just drag that in like that. Now you can either drag it in, or you can click on add, or you can actually paste from the clipboard if you've copied them into Windows Explorer. You can see they have all sorts of different levels of intensity here. And that's where you'd use this offset to move things around to get the intensities and then the scales the way that you want them to be. Anyway, this is a great presentation tool. However, if I created this and then saved this data, the problem is the files are stored in a folder on my machine. It doesn't do any good to send you this grid data. If I want to share this with you, I've got to send you all the .dat files. And that's what this export presentation with all files does, is it takes all the files that you've dragged in and all of the scaling and offset information and packages it in one zip file that you can then import using this. And in that way, you can actually create things that that you can share with people, because that zip file, let's open that zip file just for fun. And you'll see that zip file has all the .dat files that I included. This is the one I started with, as well as the actual defining data from in here, you know, the scaling adjustments. That's something you would never really want to open that up and look at its innards, because it's just technical stuff. So,
Quick question.
Yeah, sure.
So the presentation to export, once exported, coming across as a zip file.
Yes.
Is there a native format file extension for presentations by themselves?
Not quite sure. Oh, if you're asking what, yeah, presentations, I'm just using the .xml extension.
Okay.
It's just an XML file.
So
But-
the XML file is pointing to all the original DAT files, and then for export becomes a zip.
That's right. And
Got
when you export the XML file, will have its paths adjusted to wherever the zip file is. So the cool thing is people will be able to post the results in a presentation. It will include all the .dat files, all the 1D fits files that you may have used, all of your scaling and offsets and colors in the appearance screen. All that will be included in that one zip file. And so it becomes really, I'm really more talking about sort of the innards of how things work. The key concept is export what you've done here and then email to somebody and they can import it. So that's the neatest new feature. What I wanted to show you was to import a different presentation, and that is a rectified version of the "Oh Be a Fine Girl, Kiss Me Stars." You can see that, this is rectified. There's a procedure in the videos, which if you can't find, ask me about that. It's been there for a while, where you divide a spectrum by a spline fit, and it flattens it out. And again, you can see I don't have to do a lot of spacing or scaling issues because everything is horizontal. This is another classic way of looking at spectra. And again, we've got our identifiers up there to identify the items. Again, and all of these identifiers that you saw, as I implied earlier, you can turn them all off if you just want to look at the raw data. It's just the standard appearance screen. There's very little change. Yes, go ahead.
Yeah, just before we move away from this, very interesting subject, somewhat of my own naivety in the process, could this assembled series of spectra be used as a base to a automated identification of an unknown spectrum?
I suppose it could. You could drag in your new spectrum up here and then compare it to the others and visually see. But I've never done any automated work. I don't know many people who have at the amateur level. But
For one reason, I'm very interested in wide field spectrum, where you maybe have 100 spectra in the field of view, and it'd be really nice to be able to use a model like this to try to identify what you're looking at quickly.
I agree. Let me make a note of that, David. Again, it's pattern matching and a lot of fancy math and algorithms to do that, but it might be really fun to try.
Well, you have the absorption points well defined across the different spectra, so that's something to hang the spectrum on.
Sure, that's true. Listen, before we spend more time on this, I'd like to let Lauren take the floor for a bit. Lauren, I met at the spectroscopy conference I mentioned down in Las Cruces a couple years ago. And she's doing, if you're following on the forum, you've seen some of her posts, really remarkable work with drift spectra. She doesn't do any tracking with her DOB and pure video, and is really squeezing the maximum amount of performance out of her equipment, and also learning a lot. I always tell people like Lauren and all of you that you know, in the beginning, maybe I know a little bit more than you, but very quickly people accelerate past me. And I'm expecting Lauren to be answering questions for me for the decades to come. She's to the point now where I can go to her with questions on certain topics. So Lauren, let me stop sharing my screen, and she's got some work she'll share with you just to give you an idea of the kinds of things she's up to. I assume she's still here. I thought I saw her come in.
Yep, I'm still here.
Oh,
Thanks.
good. Great. And Lauren, maybe when you're done, you could post in the chat window and give a little advertisement for what's happening in 30 minutes that you're moderating, and we'll adjourn to that so people can join you there.
Oh, sure. Here, let me get it says the host disabled participant screen sharing.
Oh, isn't that nice? See, already she's able to give me a lesson on how to host a meeting. Try that now, Lauren.
Okay.
Oh, it still says only host. Oh, no, there we go. You can get in now, can't you? There you go.
There we go. All right. So I'm just I've only got a few minutes here before I need to go set up the AVSO webinar. So I'm just going to be flicking back and forth through this slide deck that I have that's normally for a much longer presentation, but it's got my spectra in it and I can put them full screen. So this is a side-by-side of one of my first spectra I ever processed with RSpec, which is the DSLR one, and one from about a year later that I shot using my DOB and the drift scanning method. So really simple. The drift scanning method is just point a telescope at a star, non-tracking telescope. The star and the spectrum are going to be moving across the field of view pretty fast. But if you shoot a video and then you register on the star or a bright emission line in the spectrum, you can tell the software, that's my align point, follow it throughout the video frames. It'll align all the spectra and you can stack them and get a much higher signal to noise ratio than if you were doing untracked. And the advantage there is that you can use large aperture. If you have a large aperture telescope on hand that does not track, that can still be better than a tracked small aperture or something. So here it's basically just an example of 12 inches versus 1 inch, because the star analyzer was on the front of the DSLR, and it made a pretty big difference, as you can see. So that's what the drift scanning method is. I'm going to skip to way later in this presentation. Yeah, there we go. All right, so there's one of my recent results. P Cygni, that was taken with the drift scanning method. The difference as to why that one looks so much sharper than the easy Canis Majoris spectrum that was on the other slide is that I've gone through a bunch of resolution optimization steps that if you're interested in the details, Uwe Zermhol, I have no idea how to pronounce his name, but very, very nice guy on the forums, has been posting a lot of detailed information about that to my forum thread that I started the other day. The basic steps are, if I can page backwards here, wait, here. All right. You have a prism that can put the spectrum back onto the optical axis so that you get a reduction in chromatic coma. Let's see, what time is it? Okay, good. And that can help increase your resolution because everything's on the optical axis. It's like collimation, but for the star analyzer spectrum. So I use the prism, except for when I get to very long dispersions like that. That is what I use pretty often. All of those are spacers. None of those are like, that's a Barlow tube, but I took the lens out of it. So there's no extra lenses or anything. I basically just cannibalized a bunch of parts from my eyepiece kit and took the optics out of them and used them as spacers to get the star analyzer grading as far away from the camera as I can without it physically smashing into the secondary mirror of my telescope. That's
amazing, Lauren.
Thanks. Yeah, it's it feels completely ridiculous setting it up, but I think the results are worth it because with that amount of dispersion, because the more spacing you add, the more spread out the spectrum gets, higher your dispersion, that's when you start getting really high resolution. One of the effects is because vignetting, you are stopping down your aperture effectively when you use something that's that much spacing, because I mean, light cone, a lot of the light cone is just impacting the outside of the spacers and not making it to the sensor. That's okay if you're going for high resolution because the vignetting increases the focal ratio of the typically fast focal ratio of a large telescope like a Dobsonian, and it sharpens up as a result. So you can see the farther down on this chart, farther down you go, the more spacers that there are. And it comes to a certain point around, I think Uwe said it was F10 at that level of spacing, where it's actually better to take the prism out, because that corrective prism adds a little bit of a distortion, and it's not much compared to the amount of chromatic coma that it removes at low dispersion. But when you get to high dispersion, the chromatic coma is gone by itself. So you might as well take the prism out and get a little extra resolution bump that way. So,
Right. Just one thing, Lauren, if I may jump in for a moment.
go ahead.
We at some point last year, you gave a great presentation where you talked about the prism, and we had a huge spike in prism sales. We went from like 4 to 8 lifetime. We don't sell a lot of prisms. And I just want to make sure people understand that the prism doesn't solve all your problems. It's a really specialized device that you only start using after you've mastered a lot of other of the resolution issues. Can you speak to that for a moment, Lauren, just so we don't get another flurry of sales?
Well, I don't know if a flurry of sales would be a bad thing exactly, but you're right that there's some other stuff that you need to do to make sure that you're getting the best resolution. Focus is number one, especially with the prism. The prism, see over here on the right column is spectra with a prism. So see how the spectrum is getting pretty tall by the time you get down to high dispersion? That has to do with astigmatism that's introduced by the prism. And what that means is that if you're just focusing by looking at the spectral strip and trying to make it narrow, it'll be out of focus. Those spectral lines will be flipped over horizontally and you'll have a blurry mess. So the best focus, and I think this is also true without a prism, but it's exaggerated by the prism. The best focus is when the spectral lines are sharp, and that will happen when the strip looks out of focus if you're not zoomed in. Sure. So you really have to zoom in and look at a bright spectral line like this, or a really dark one, and then go until that looks sharpest to your eye.
Lauren, have you been able to quantify the amount of defocus from the star focus so that you can hit focus exactly without trial and error in subsequent runs, or do you do the focus every time?
I do the focus every time. It's a significant amount of defocus. You can't focus on the zero order star. Yeah. It's part of the advantage of the prism is that the prism makes the zero order star a blurry mess, which means that if you have multiple stars in the field, you have to worry less about overlapping because the star is not going to masquerade as a sharp spectral line. It's going to be a big blob. So it'll be more obvious if you have any overlap, and it'll be less likely to just look like, oh, look, this star suddenly has emission, and then it's just a background star.
Now, as you've increased, it's unfortunate that we use this word dispersion, because I was going to say, as you increase angstroms per pixel, which basically lowers the dispersion. Let's say it in the vernacular. As you spread the spectrum out more and more, what's happened to your exposure times? Has your telescope been large enough that you've been able to accommodate the dimmer image because it's so much more spread out?
Yes and no. My telescope is large enough that I can get away with shooting high dispersion spectra, like with that ridiculous 8 inches of spacers. I can get away with that down to, well, as you see here, P Cygni is like magnitude 5.5. Mm-hmm. However, some of the faintest targets I've gone for are more like magnitude 9, and I couldn't get that at the highest dispersion. I'd have to go down to maybe 4 inches spacers or less to get a good signal to noise ratio on magnitude 9.
Yeah.
The longest exposure I ever use is 1 second because of no tracking. So
how do you calibrate?
How do I calibrate, like for wavelengths?
Yeah. Once you.
So I do that by.
All that.
I do that by loading the spectrum into RSpec and basically looking at which spectral lines, like I'm going to go to, or here, well, actually, no, that's not a graph view. Okay, here, P Cygni. I know that this bright emission line is hydrogen alpha. This one over here, H beta. So I know some reference points for the wavelengths. So I start with a rough calibration using just the most obvious features. And then that can help, like if I know that there's a lot of helium emission in P-Cygni, but I'm not sure exactly what the line wavelengths are. I can get a rough calibration using the hydrogen lines and then turn on the helium line overlay that's built into RSpec and look at, okay, yeah, that must be a helium line because one of those lines landed right by it. And then I can add that as an additional calibration point.
So, and that reminds me of something, and that is, first of all, you're right. There's no harm in sales. I mean, I like making a little money, but I'm also, you know, I think some people, as a result of the wonderful results you've been getting, have said, "Oh, I've got to get me one of those grisms, you know, one of those prisms," and their skills aren't to the point where they can make maximum use of that. So, one of the things I'm wondering is, would you recommend, and this isn't a rhetorical question, I don't really know, would you recommend somebody before they get a prism experiment with greater and greater sensor, grading to sensor distance to determine, first of all, whether they can handle that, whether they can work without a zero order, how focus works, all that. And then if that's interesting and they've hit some limits, then move into the prism? Is that a reasonable step to take?
I think so, absolutely. In fact, this spectrum that you're looking at right here did not use a prism.
Oh, okay.
Because the prisms actually have a very slight bit of internal reflection that they introduce to your system.
Mm-hmm.
So what wound up happening when I try to go to high dispersion on P-Cygni using a prism is that I'd get little reflected emission lines, right? And that was messing with my line profile. So one thing that I've wanted to measure for quite a while is P-Cygni line profiles, the little zigzags where you have a blue shifted absorption, but I couldn't tell whether I was getting that because I had this ghosting going on in the spectrum. And I was like, well, if I see that, it could just be a ghosting, right? So taking the prism out actually completely removed the ghosting. So I'm assuming it was internal reflection. And I was able to tell, by the way, that it's ghosting and not a real feature of the spectrum because when I would focus, I'd be zoomed in on a spectral line focusing. I could watch the ghost move as I focused. So clearly it's something in my instrument, not in the star.
That's
Lauren,
fascinating. Go ahead.
Lauren, two questions and one. Fantastic work, very, very impressive. Could you speak to your stacking method, whether you use something like Registacks to do the line stacking? And secondly, regarding the prism, what about if you tilted, I know the mechanics would be a little bit more difficult, but if you tilted the grating to, you know, the 1 or 2 degrees required to have the dispersion running down your optical tube, would that be any aid to you rather than having to put a, you know, a nonlinear affecting a prism into the system?
Okay, so I'm going to answer your second question first. I unfortunately, transmission gratings don't work that way. And I found out the hard way by getting like 16 hours into designing a slit spectrograph based around a rotating transmission grating and then realizing, wait, they don't work that way. The light, unfortunately, the zero order will always pass straight through the grating no matter the angle of the grating. Same thing with the spectra. The dispersion might change a little bit because of the effective lines per millimeter on the incident light is changing. As you tilt it, more of the lines they're getting packed closer together, right? So you get higher dispersion, but it doesn't actually tilt like a reflection grating. Yeah, you can control which direction the spectrum heads off in that way, but not really with a transmission. Your first question was about stacking, right?
Correct, yeah.
Okay, so I'm gonna go back. Luckily I have in this presentation. Okay, so here is a program called Serial. It is a freeware program that you can download, open source, and I shoot .sir format video files, which is pretty common. You can do that in SharpCap. And then those .sir files can be loaded directly into Serial. And then Serial, if you watch this video here, I'm going to draw a selection box around the star. And you can do that for anything star-like. So like for my P-Cygni, it was too high dispersion. The star wasn't in the field of view, but I was able to select the hydrogen alpha line because that looked enough like a star to Serial. And then there's a 1-star registration mode. I tell it to track the star, hit go register, and it registers within like a minute for each video. Now, I have tried Registacks, Auto Stacker, Deep Sky Stacker. I've tried all kinds of stackers in the past. None of them have worked for my drift scanning data except for Serial.
Will Serial handle static images like Registacks does and the others?
Yes, it will take in a sequence of fit images, a sequence of GIF images, PNG, whatever.
So
You
just-
do, for anything that's not a .ser file, you do have to go through an extra step in the file conversion tab where you select it all and you tell it this is one set of images, but otherwise it's the same.
Great. You know, I realize now, Lauren, we really should have devoted a whole session to you. I just love hearing what you're doing. I'm really excited and delighted.
Robert Reeves uses this for his lunar images too, so definitely.
Good, cool. So if those of you who are here sort of looking for something to do, one thing you might try would be to capture a series of long images. You probably have tracking, unlike Lauren. We've been really lucky Lauren didn't have tracking, so she's been able to pioneer all these steps. But capture some images if you're not familiar with stacking, and since Cyril is free, it's as are Registax and others. But if she's having good luck with Cyril, it's a good bet that it would work for you too. Before we run out of time and Lauren has to leave us, two things. Lauren, do you want to, in the chat window, put your website address where she describes more of her work, as well as maybe give us a little infomercial and a link to the session that's coming up in 20 minutes?
Let me
Sure.
guess.
And-
She the tie-dye astronomer?
She's a tie-dyed astronomer.
I thought so.
Who's that speaking? I don't see you.
I'm sorry. Did I turn off my video again?
No, you're
Sure.
on.
This is John Sillison. I think we met the first time he did his Saturday presentations. And in fact, I've had one of my club members ask me for your website because she was interested in what you were doing.
Oh, very cool. That's great.
So can you pop up the chat window, Lauren, and
Yeah.
share your data?
Yep. I will go ahead and share that stuff, and then I'm going to need to hop out and go get that webinar set up in about.
I figured. I can't. I mean, I've already praised her. I don't want to get too carried away because it'll sound disingenuous, but it's really exciting to see anybody, and especially somebody who's new and young, doing what she's doing. And she really has pioneered a lot of interesting work. The AVSO and many others have sort of spotted her as a rising star. In fact, a star already. So fortunately, she's busy with her keyboard, so she can't be sitting there blushing. Oh no, she's listening now. But anyway, Lauren loves answering questions like many of the rest of us. So don't hesitate to reach out to her. And what is this session coming up in 23 minutes? Or 20? Yeah,
We're going to have Dr. Steve Howell talk about a study that he did on bright giant variables using AVSO data. And then after that is Dr. Juan Echevarria, who's going to talk about a cataclysmic variable called DW Cancri, which was displaying some weird behavior. So it's going to be some pretty fun variable star science stuff. If anyone wants to join that, it's at 2 p.m. Eastern time.
Great. Well, thank you, Lauren. I appreciate it. I just pinged her last night and said, hey, could you jump in? And she's really risen to the occasion. I think a year ago, if I'd done this, we might not have gotten her to sign up to speak. And she today, I mean, we're amongst friends, so it's an easy talk to give. And she did great at it. Thank you, Lauren.
Thank you, Lauren.
Bye.
Good. Any comments before we move in and have Tim show us some stuff? Okay, so Tim, do you want to share your screen and show us the fun that you've been having?
Sure. Can you hear me?
We can.
All right. I'm going to share my RSpec. Here we have, I've been working on, oops. Can you see my screen?
We can. It says you started screen sharing, but it may be sharing a video card that doesn't have a data coming to it or something. I don't know.
No, it says screen sharing. Your screen sharing is paused. I don't know why.
I've
Yeah,
never.
it's just spinning on our site.
Resume share. Resume share. Stop share.
There. Well, you stopped it. Yeah.
Yeah, we'll try it again.
There we go.
Are we good? All right. All right. So, along with Lauren, I use my star analyzer with considerable spacing, and as a result, you end up, you can't fit the whole spectrum onto one sensor. My sensor, I use a webcam. Sensor's pretty small. In fact, you can't get the zero order on for alignment. So that's one of the challenges that I have is just how to stack all this stuff in the first place. But that's not what I want to show you here. When Tom showed me his presentation manager thing, I was like, you know what? I can use that, not for making pretty things, but for stitching my panels together. And so I want to show you how I use his presentation manager. The old OS2 thing. I still think you should call it presentation manager.
I may change it. I just don't want to confuse anybody. But of course, anybody who's old enough to remember the OS2 presentation manager can't remember it because they're old.
OS2.
I've popped up the presentation manager. Can you see that pop up right now?
Yeah, we can.
Okay, all right. So I have Procyon. I did the other night. I'll drag the panels over to the presentation manager. I have one from 3,500 to 5,600 angstroms. Here's the next one. Here's the next one. I've got 5 panels all told. Here's the next one, and here's the next one. You can see that I have, different exposures, different ADUs. It's all kind of mishmashed, but you can see everything all together. So I will choose colors that kind of match where these things are. Yeah, and let's switch to the dark background because it shows up better that way.
Yes.
And switch to the colors to match kind of where we are in the spectrum, just because I find it easier to keep track of things when they have different colors. And here's all my data sitting there. Now I can say, well, does this all fit together correctly? And I can say, well, I can scale. The green one needs to go down. I can scale that down. Yeah, they all need to go down, in fact. I can scale yellow down, and I can scale orange down. And close enough, I guess. And red. And I'm not actually assembling the mosaic here, but I'm getting it to the point where it all goes together, and I can tell my data is calibrated consistently. I don't have any bad fallout from something bad that happened, during the acquisition process or anything. There's Procyon. And then I can say, well, where do I want to merge these profiles? I can spread them out. I can find a spot that I like and say, oops. I don't want that to be blue. Why is that red? Here we go. There we go. I can say, well, there's a good spot right there. The blue, the profiles are very similar at that point. I will typically show a measure line just so that I could, whoops, that's not a measure line. Where's my measure line at?
That should be it. Yeah, there you
go. I just missed. And that's about 4,981. So I have some software, some scripts that I've written that I can say, take these two profiles and make them one profile with the seam at this particular wavelength, and I'll do that all for each of these panels where I want to make the join, and I can use this to assemble my my mosaic, and it takes the process of assembly from maybe for 5 panels, maybe 3-4 minutes per panel, down to I'm ready to go right now. I got to write down these scene points, and I'm done. So I was really happy to see this feature coming. because that's all basically all I shoot is mosaics, because I have such a tiny sensor. I can't get everything in, no matter no matter how low my dispersion is. So that's what I showed Tom, and Tom kind of had not even considered that there was perhaps a processing use for this, as well as a presentation use for this facility. So
Yeah, Tim, just Mike asked earlier, and again to reiterate, the reason he has just short pieces is because he's doing some really high dispersion, really spread out spectra here. He can't fit them, as he mentioned just a moment ago. He can't fit them all on his sensor, and that Lauren faces that too. That's one of the challenges of getting into higher resolution, is that you end up, and this is Star Analyzer 200, is that right?
yeah, it's a 200, and I think my spacing is around 110 millimeters.
So you can see in the upper left-hand corner above the profile, it says angstroms per pixel 1.6. What kinds of things are you seeing at that resolution that you're not seeing at a dispersion of, say, 10 or 8 angstroms per pixel, Tim?
Oh, yeah. So let me load up a different.
Tim,
Go ahead.
Tim, before you go, because this is extremely interesting, in the blue and the green merge, on the left-hand edge of the merge of the green, there is a tall spike of emission which does not correlate to the blue. Is that an artifact, or so if you look at the very left-hand corner of the green, and would that give false information?
That's just an artifact of stacking. I will never use a panel out to the edge. The closer you get to the edge, the more unreliable that data becomes because of the stacking process. So that's completely spurious. And in fact, I'll look at these big broad lines and I'll say, which one of these do I like better? And I might make a choice about where to make the scene based on which one I think is actually better from a signal to noise ratio or whatever. You can see over here my registration has gotten a little off. I would not use that data over there because it's not linearly registered, and I just throw that away. But you can see as we go across that we do get good agreement between these profiles, which is validating as well. That you've got decent data. Now you can see my blue. I'm at the other edge of my blue, and it's crap over here. I would throw that away as well, right?
Yeah. Just another note here. It's always fun for me when somebody, and it's easy to do, thinks about and uses a feature which I hadn't anticipated in a manner I hadn't anticipated. And one of the things I'm going to be adding before we release this is a capacity to actually take this multiple profiles here and select and splice them or stitch them together. Tim's doing it outside using software that he wrote. But to stitch them together, there is a stitching capability in RSpec already using the mask screen. But this will be even more effective for people who have a need for this. Again, it's a rather rarefied because it's a higher resolution imaging than most of us do. But Tim, you were going to go to another screen and show an example or two. I'm putting you on the spot with that as to the kinds of things that people might be interested in looking into.
So here's Capella from the other night. Let me pull that up. Well, first of all, I got to close this. No, here's Capella. Turn off the measure lines. So at higher, your question was, what do you see at higher resolution that you don't see? Yeah, so let's pull up my registration lines here. Yeah, this may not be a very good one. I have, let me pull another one up where I actually, can start to see the split.
Boy, is he going to give me grief after this Zoom session about throwing this curveball at him,
of the sodium line. So here's the sodium line in Betelgeuse. This is Betelgeuse's spectrum from the other night. You can see that I've started detecting the split. I wouldn't say that that's completely resolved at this point in time, but it's there, and that's nice. It's kind of nice to see. Hey, that is the doublet, the D1, the D2 actually call out. You can see detail in the magnesium triplet here. Now it's not all that wonderful, but there's the B4 line. Here's the blend of the B3 through B1 line. So you know it. Let's see here. Yeah. I mean, you can see stuff like that. You can see these now. I can also bring up one that's not at that high of a resolution. Like maybe this one here. Oh, it's not put together. That's not what's going on here. Yeah. All right. Oh, I got to bring that up. I'm sorry. Yeah, Tom, you got me on the spot. You know.
Okay,
so
no, it's not a problem at all. We can move on. But I appreciate your showing what you're showing. Again, my concern is I don't want everybody to go away going, God, I'm not the right stuff. I'm not doing this, 1 or 2 angstroms per pixel resolution. There's plenty of interesting projects and that don't require this kind of resolution. On the other hand, if it's the kind of thing you want to experiment with, you can discuss it on the forum. And it occurs to me that maybe, what do you think about this, Tim? If somebody wanted a goal sort of to push their skills and they felt that they already had focus and stacking and those things under control, splitting the sodium D line would be a measure of a certain amount of skills and quality that they were getting on their spectrum. Does that sound reasonable, or is that an unreasonable goal?
Yeah, no. In fact, can I stop sharing my screen now? Are we done?
I'm sorry, your mic isn't quite stable today, Mike.
I got somebody with a chainsaw outside.
Oh.
I can stop sharing my screen now. In fact, that was my first, kind of my first resolution goal, objective is I want to split the sodium line, and you have to pick the right star because the sodium line is not very prominent in the hot stars, and it's almost buried in the cool stars. So, but you pick a G star or an F star or K star, and you can split the sodium line, and that was my first benchmark. Once I saw that split, I was like, okay, yeah, I've achieved that, So then, what's the next achievement, So
that's fantastic. I mean, it seems. I hadn't really thought it through, but in terms of projects, again, to emphasize, you really want to have your licks down and be able to capture spectra of common objects at 7 to 15 angstroms per pixel. Once you've done that, and again, the challenge when you start spreading things out is you're not going to have the zero order on your sensor. And so calibration becomes a real challenge. And I'd encourage you to be careful in bragging about this kind of thing, because there are purists who say without the zero order, we can't help you. And it's true. It's tough to help you if you don't have a zero order. You're sort of on your own trying to find, defining features that you can calibrate with. With Betelgeuse, how do you do it, Tim, with Betelgeuse? How do you actually do your calibration? What lines do you choose, since it's a cool star and you don't have your Hydrogen Bomber series lines to key on?
Yeah, Betelgeuse. The first time I shot a cool star, it might have been Betelgeuse, it might have been Alpha Hercules, but they're cool stars. And I looked at the spectrum and I'm like, what in the heck is this? Like, I don't even know. I couldn't tell you. Well, there are benchmarks in Betelgeuse, in those cool stars. You can see the sodium line actually is fairly prominent still. The magnesium line is fairly prominent, and you can use the Pickles reference. And you can compare these peaks to the peaks that you're seeing, and the bottoms of these troughs, these titanium oxide, big, broad absorption features, and you can begin to pick them out. And now I recognize them, and I don't really. It's not a challenge for me anymore. But before, it was like brutal.
Cool. One trick I wanted to show, and that is that if you're, suppose you're calibrating here, and I've got some broken software now that isn't allowing me to click here. So because this is a development machine we're looking at, and that is 469. And I'm going to just put in 400 for fun there. So my calibration is wrong. Apply. Okay, so there's our calibration. Let's turn off, reset the default and hide all labels. No, I'm not going to hide all labels because I'll forget I did that and wonder why none of them are showing later today when I'm working. So suppose I did a calibration. Now, maybe I don't even have the zero order visible, so I'm just guessing. After you've calibrated, you can, with the calibration tool, especially if you have the zero order, this is a worse example than what I thought it was. You can change your dispersion here. What that's changing is this number. You use this for zero order calibration, which you definitely need to know how to do before you move into higher and higher dispersions. But you can, this is changing that number, which allows you to sort of scrub back and forth until your bomber lines match up. You can see there, I'm just scrubbing, looking on the left to see where the blue lines intersect the data. Very primitive approach, but you can see as I watch this line finally line up on that feature and this on that feature. So this is a way that you can sort of do some trial and error matching. Now, as Tim mentioned, there's no bomber features visible. There's no bomber features visible on the cooler stars. And I wanted to bring up that Gray and Corbali again. To show you here on these different star types, you can see the sodium line. And again, all I know is what I'm showing you on this graph now. I don't do a lot of this hands-on. It looks like you're going to need the cooler stars to see the sodium. And the problem is when you get into these cooler stars, the hydrogen beta feature and the hydrogen alpha features begin to go away. So as you're trying to navigate, you can't use this as your calibration tool. So I wanted to show you one other example of this presentation or presentation manager. Tim's going to force me to add that word manager there, I can tell. And that is, there's a guy on the forum, his name is Rainer. He's from Mexico. And he sent me this data that he captured in December. Rather than different star types, this is a time study, a longitudinal time study. You can see the different dates going by there. And the first thing I'll show you is, this is one of the first files he sent me, and you can see he's using ELISA. Let's just drag that over. In fact, I'm going to drag it over one more time so we have it there twice, because what I want to show you is look what happens to our legend. The default legend here is the file name, and his file names are really long. And that's why I have this column here where you can, just type in whatever you want there to shorten the label that occurs there, so that you're not using up half your screen on a long self-descriptive label. But what I wanted to show you, let me just clear this, is some of his data. If I can bring it up here, clear all rows, yes, there we go. So here's some of his data. This is in the Windows Explorer. I'm just gonna highlight a whole bunch of these. Fortunately, he named them in date order, so they'll sort by date. And again, if the month and day, as you can see, the day is less than 1 digit, less than 2 digits, he put a leading 0 in. So this all sorts properly. So I can just drag all those over here. Well, that's sort of a mess, right? That's where, again, this offset applied to all profiles. Watch what happens as I drag this offset. It just sets them off so you can start comparing features. Now, these are all different dates. And so at this point, if you were studying something over time, you'd be in a position to be able to notice changes that occurred. But again, it may be that those changes are a result of the object changing, or as David Britz mentioned a few minutes ago, it could just be a change in the equipment or the seeing or something like that. In Tim's case, it was at the edge of his sensor. So this is the primary new feature that's here. A couple things I added which just were bugging me. Down here, these are buttons that just will open the folder that auto open is saving new files in. Again, as a reminder, if you're not using this, if you're capturing FITS images with some other software, you can configure the software to monitor a folder and automatically open those files as they come. And now you can easily change what that folder name is that RSpec monitors, or even better, actually go to that folder and see what files are open. Unfortunately, if we go there here, you see I've been looking at some Far Side cartoons. Might as well take a risk and see what it is. All right, so there's a little joke as we wind down. So he's great. By the way, Gary Larson lives here in Seattle, and a friend of mine, I think it was probably 20 or 30 years ago, he is retired from his career, but this friend was a guy who did ferro concrete, ferro cement, and he, like a lot of zoos all over the world, they'd fly him in to create these, structures that they sometimes would then add horticulture to for zoos, for enclosures. And Gary Larson hired this guy to create and install a sculpture at the bottom of his swimming pool. And it was a full-sized human body that he had secured at the bottom of the swimming pool, just to scare people. Anyway, so these are a couple minor features that I added. I'll tell you one other, a minor one. I did this because Rainier was looking for it. He said, these lines are too thick. They're hiding data. I think maybe he was splitting hairs. I love working with him. I don't mean to throw him completely under the bus, but now you can change those line widths and lower them down on the display here. If you go too low, they may disappear, which is why I have them as fat lines here. There's that. And a couple other things. One guy, I don't have his name right now. I don't think he's here though, who's doing a fair amount of higher resolution spectroscopy. And he said, every time I load a freaking image, I got to crop it. I want to crop it because I don't want all that empty airspace at the end. Couldn't you allow me to select the cropping region? Right now, you have to hold the control key down and bracket in the region you want to crop. And so I'm going to add something here, hopefully before the release, where the little pull down arrow like these that will behave somewhat like that, where you can enter or select the crop region that you want to use, and then maybe even make it automatic. I'm very hesitant to add automatic features like this because it's really easy to get an automatic feature turned on and then forget that it's on and not know why things are happening automatically. So I try and to not make things automatic. And frankly, even adding these two buttons here was a debate for me because one of the things I've tried to do is keep RSpec the screen as simple as possible so that newcomers as well as experienced users don't run into problems with complexity. And the other thing, which Tim kept me honest, the original implementation of this had a button that you'd click and a little offset window would pop up and you'd do this offset or the scaling in a pop-up window. And it was really a pain in the neck because then you'd have to close it and move to the next item and adjust it. And so Tim complained enough, which was basically once, that this should all be non-moded. That's the key term, is when a piece of software pops up a window that stays there and you can't do anything else while it's there, that's when it gets really bothersome. Like this is a moded window. I can't do anything, and that's reasonable in this context. But most of the time in life, for example, this appearance window or a calibrate window, you really don't want the window dominating your access. You want to go over to other places and be able to do other things. Anyway, so not a boatload of new features. This wasn't a simple one to create, but I'm delighted it's there. It's not one that everybody will use, but if you want to experiment with it, that's one of the reasons that I included these presentations that will be available under Sample Spectra. And you can pull those up and play around with them. I think that's the, I was also going to give you a link to a PDF of this document. Let me grab that right now. I'll put it in the chat window.
Tim, may I
Sure.
make two observations?
Sure.
And first off, this has been a great meeting. This is my first meeting and really enjoy what was presented today. Wonderful work. It seems two things are happening. Number one, the ability to stack images is to me a very powerful tool. I use RegistX for regular astronomy imaging and know the power of its ability to improve resolution. So the ability to stack would be a really nice tool to have, even a rudimentary stack in RSpec. And the other thing is that the types of sensors that are available now is increasing rapidly from full format down to video. And so the ability to subsample a dispersion with large format detectors would perhaps lead to larger dispersion sizes and higher resolutions. So there's a couple of interesting things happening, especially with the ability to stack multiple time exposures to higher resolution. So the ability to stack and different size formats, I think, is going to be an opening for this hobby.
Yeah, I've always resisted trying to reinvent the wheel. Stacking is something that people spend thousands of hours coding. And my feeling has always been,
what else are you going to do, huh?
Yeah. I mean, there is rudimentary stacking. There's no registration, but on videos. And it's really remarkable. I think people have probably seen it in some of the tutorial videos that we that are on the site. I mean, to me, and I'm not sure I showed this aspect of it. Here's a Vega video. I'm going to just rotate it around. I wanted to show you that stacking because it's a marvel to me. It really is. Here's a hydrogen alpha feature, and you can see it. It's pretty noisy here. Here's John back again. So there's that hydrogen alpha feature. And when we turn on, and I called it averaging. It was a mistake on my part. I thought I'd keep things simple for newcomers. But when we turn on stacking, there's no registration going on. But you can see at 2 frames a second, it's only taking 5 or 10 seconds to get that stacked. Now, to be honest, I did do some work and never have released it, where you would indicate where the zero order is, and then it would do the registration also. It was. I think most people who are imaging have used a stacking program of choice. I didn't feel like the integration into our software would add an enormous amount. And frankly, I'm lazy. And other people have done a really nice job stacking, David. So that's my thinking right now. But, it's something that's on the table. I've thought over the years, and you're bringing it up, will give me an opportunity to consider again whether it's something I'd want to do. Thanks for that feedback, David. Other feedback, comments that people may have?
When's it coming out?
Good question. Oh, that's Conrad.
Yeah.
In the era of COVID, I've gotten a little more casual about my work hours. I'll tinker for 2-3 hours a day, 7-8 hours. My wife thinks I'm down here working all the time, but I'm just surfing the web. I guess she's not back there. So, but it's going to come out in the next couple of weeks. I've got people lined up to do some beta testing. If any of you are interested in getting an early copy, you're all experienced users for the most part. I'm happy to send it to you if you just want to play with it. If you're willing to suffer and have to roll back to an earlier version if it crashes, I'm more than happy to I'll do an initial sort of beta release just to make sure there's no big gotchas. And then I'll probably make a private release to any of you who want to get involved. By the way, there is now, so let me know if you'd like that URL. If you open the chat window, and there should be an option at the bottom of your screen to open the chat window, you'll see a URL for the PDF of that Gran Kobali. Again, that's just a chapter and a half that is interesting reading and accessible to non-professionals like ourselves. Other feedback people may have?
What version is this, Tom, that's coming out, please?
That's a good
version
question,
number.
John. I don't want to go to 2.0 because that implies like major new capabilities. So I keep up going from 1.9 to 1.9.47, I think is what I'm at internally here. It'll be around 1.9.50. You can always ping me on the chat app on the site or email me and I'll let you know what the current version is. You can also check, once it's really full and available, under help, there's a check for updates option that will also allow you to check whether you are able to download it. Other feedback? Anybody else? Oh, no link yet, says Nigel. Oh, I guess I forgot to paste it. Thank you. Oh no, you have to scroll up a fair amount, Nigel. There it is again. Oh, I sent it just to Steve. No wonder. I had a private chat going on. There it is. There you go. There's that link. And that link
That's
will
one of
only
the
be
worst features of Zoom. Somebody private chats you, your chat's data with them.
What was the end of that, John?
I said that's one of the worst features of Zoom. Even if somebody private links to you to chat, all your chats go to them without reverting back to everyone.
Yeah, that's true. And I just fell right into that hole. I'm glad you said something. So Other feedback and people doing any projects or questions? I'm hesitant just because what we've talked about today is typically higher resolution stuff. I don't want people to feel they got left behind. There's, of course, tons of interesting projects that we can do. Wolfrey A-stars are one of my favorites. Just because of the emission lines that we get. So if that's something that you're looking for a new project, you might think about Wolfrey A-stars. What else? Any discussion items? Don't all jump at once. Bueller, anyone? Well, listen, I'd like to thank you all. RSpec has meant a great deal to me. I appreciate the opportunity to serve you as a community, and your feedback and support have meant a lot to me. And it's been a real honor to be able to give you all tools and the help I have to learn this exciting field. I tell you, my biggest challenge these days is the same as it was 11 years ago. You're all the cream of the crop. How you jumped in is, I can't exactly explain how it is people make the jump. I wish I knew more. It's all about marketing. At this point, I've given about 350 webinars to clubs. It was easier this last year. I gave about 150 this last year. If you have a club that you think would like to hear me speak, I'm happy to speak. Besides that, and a few articles in Sky and Telescope or Astronomy Magazine, posts on Cloudy Nights or Facebook, it's really hard to get in touch with what I assume are the other, say, 50 to 60,000 amateurs who have cameras. And like many of you, did some visual imaging and decided you wanted to do a little science with your equipment. So I'm always looking for suggestions on how to get in front of amateurs, because I mean, from a business standpoint, but also from a standpoint that the pleasure you got, we should share. You know, it's just so exciting for me. I wish you could see the emails that I get from guys like you who say, "Oh my God," and you know, I can't believe that. You know, I was looking at Vega. You all know that thrill, and so it sometimes it feels like Santa Claus, but I don't know where the Christmas trees are to deliver the software to newcomers. So any suggestions you all have over time as to ways? Oh, NEAF, of course, going to conferences. Any other feedback people have? Projects you've been working on? Questions you've got?
I have a question.
Oh, sure, John. What's up?
Trying to hold my hand up.
I saw. I was wondering if that's what that was.
Yeah, sorry. There are two files in the drive. They both seem to have the same name but different sizes.
Oh, that's interesting. I don't know. Let
me
me
Chad and something.
Actually, I thought I was sending just the file link, but it looks like I sent. One's chapter 1 and one's chapter 2 partial. So, and in fact, I'd actually—
Gray and Corbali?
Yeah, Gray and Kobali. So download those two from that folder. I've got both of them in a zip file, but I guess I grabbed the wrong link. Thanks for asking that.
Yeah, it looks good.
Good. Well, listen all, thanks again. Stay in touch, reach out to me. John, you probably, Drummond, have the record for the longest distance visitor. Thanks for today. Yippee. And we're envious of the lifestyle you've had for the last year, John, as well as for the sanity and leadership and citizenry. So congratulations on that.
Thanks.
Other comments, social discussions? Norman, I like your background there. That's nice. And Greg, I spoke to your, I've spoken to, how many clubs do you belong to? I think I've spoken to 3 clubs now that you belong to.
4 now.
Well, I'm glad
I've spoken to 2. Oh, actually 3, because I rejoined Skyscrapers since they went virtual. Because I live in Florida now, and Skyscrapers I was born and raised in Rhode Island, so I got married in 1990 and relocated down to Florida. So I couldn't really do much with Skyscrapers. But now the only good thing about COVID is it's brought everyone together, you know, from all over the country, even the world, you know. So different clubs are interacting with each other that normally would never do so because of distance, you know.
Yeah, and I mean, most of us are relative introverts anyway. That's why we like our nerdy toys. So it you know, in terms of socializing, it's sort of in some ways, I hate to say it again, make sure my wife isn't standing in the doorway.
If I could ask Gregory a question real quick. What part of Florida are you in?
Oh, Sarasota.
Oh, you're in Sarasota. I'm in Pensacola.
Oh, you're in Pensacola. Oh, you're way up in the Panhandle.
My problem is the weather is never really suitable for this. Every once in a while. The weather must be better down there.
Well, in Florida, we're kind of lucky because we have three things going for us as far as imaging goes. Christopher Go, one of the planetary imagers, was saying, he's out of the Philippines. He's saying three good things to have is, one, be closer to the equator because the planets will be higher up in the sky. And even a lot of the constellations, like, Orion is a lot higher than it was in Rhode Island, and Lepus and some of the more southern constellations. And two is to be near the water because the water stabilizes things rather than be landlocked. And then the third thing is a jet stream. Now, we have 2.5 in Florida because sometimes the jet stream does come over us. So I check the Weather Underground website, and they have whether the jet stream is above us or not. And when the jet stream's above us, the scene just goes to heck, but when it's not, it's pretty steady skies. So the skies are really steady down here. Yeah, we do have the humidity factor, but some days it gets perfectly, after a good rainstorm, you get perfectly clear and there's not a cloud in the sky.
I usually find after a good hurricane, it kind of dries up.
Yeah, it dries it up. Yeah. So we're kind of fortunate. The seeing is good overall in Florida, which is good. And that helps with spectroscopy too, because you're not getting the stars scintillating as much,
Yeah.
Thank you, Gregory. Thank you.
Tom, can I just say something?
Sure, Steve.
One of the things I've done a lot of catalogues for Wolf-Rayet stars and planetary nebulae. I've done loads of spectra of those. But one of the things I have done is use RSpec to scan across a planetary nebula to look at the elemental distribution across the nebula.
Very cool. Were you
Can
able
I
to
share,
see things that...
Can I share a screen with you?
I hope you will. Thanks. I was going to ask you. That would be fantastic. I'd love to see it. I'm sure everybody else would be too.
Okay, hang on a sec. See if I can get this. Where are we? Share screen.
While he's putting that up, Port Denver, 18 inches of snow coming.
God.
Are you in a car, John?
Does it show?
Yeah.
That's my steering wheel. Put it up over the odometer so I can get some perspective.
You're not driving, are you?
Oh, thank goodness, no. I'm parked in a Costco parking lot.
Oh, Costco.
The last time he did this, I was in a post office parking lot.
Okay.
Okay. Can you see my shared screen?
We can.
Yes,
yes.
Okay, so this is the Ring Nebula. You can see the spectrum of the Ring Nebula. You see the lines there. Can you see my cursor?
Yes.
Okay, so what I've got is a very narrow analysis window, and what I've done is scanned this across the nebula, and you can see, if I play this video, you can see the spectrum changing as you scan across the nebula. So we're coming into the top of the nebula. You can see lots of hydrogen on the right-hand side, which disappears towards the center. And then it all comes back again as you move to the other edge. And you can see the nitrogen either side of the hydrogen building up.
Can you pause like at the bottom of the, just up from the bottom there?
Yeah, I can go back to here.
Yeah, like right there. That's great.
So we got hydrogen alpha as the middle of these three.
Yeah.
With nitrogen either side. And what this shows is that the outside edges of the Ring Nebula, which are red, is mainly due to nitrogen, because the hydrogen is fairly well distributed right the way across. So this is the nitrogen and hydrogen region, and these are the two oxygen lines, and this is hydrogen beta down here.
So
what you can
go ahead.
Yeah.
The triplet that we're seeing at the very right of the profile area. Yeah. So what is that? One element, or is that several elements, or what?
The central line is hydrogen alpha.
Okay, you said that. That's
and
right.
The two either side are nitrogen. Nitrogen too.
Well, so the interesting thing is you see the height of those elements, the ratio of one to the other changing as you move through. So you're looking at theoretically how density of the gas changes in terms of the ratio of the different elements changes as you move through the spectrum, which is very cool.
And I can show you that. If I go back to here, this is a plot of the intensity of the various lines as you go across the two directions of the ring nebula.
Look at that.
So this is, you can see this bright red here is the nitrogen, which there isn't much in the middle.
Yeah.
The fainter red one here is the hydrogen alpha, which exists all the way across. But basically, this red fringe around the ring nebula is nitrogen. And then you've got
go ahead.
the oxygen, which is what gives it the bluish glow in the middle, is this oxygen.
And what's the image to the right?
This is just the same thing across a different axis.
Oh,
so this one is across this axis, and the second one is down that axis.
Yeah, and both of them show, but on the right one, it's clear. On the right side of the profile, the red peak and the blue peak, you can see clearly that there's concentration of hydrogen alpha is closer to the edge than.
No, that's nitrogen.
Oh, that's nitrogen?
Hydrogen alpha is the fainter red one, which is right down here.
Got it. Mm-hmm.
So it's not very clear.
That's very cool. Reds are pretty close to one another. That's
just to understand the new features, Tom, would this be an excellent candidate for presentation manager or what?
I don't know. Maybe. I don't see why not. That's very cool. Really neat.
Thank you.
How did you generate those curves?
I've got an image of comparing this with some work that some scientists did with the Hubble Space Telescope with dedicated filters, with oxygen filter and nitrogen filters. And the distribution I've got here is pretty close to the Hubble results.
Wow.
But I've used narrowband.
Congratulations. That's really neat. How long ago did you do this?
How long ago did I do this?
Well, not that long ago.
No.
Yep. Really neat. What do you have any other projects in mind or that you're working on now, Steve?
I want to try and get some. We work closely with a university because we've got this big 24-inch telescope, and we get our local university has a cosmology course, and we do work with some of the students. So I want to get a student to do a project on this and try and do some proper analysis on this.
Very cool. You'll see again, note at the legend on the bottom, he's using an L-high-res slit device, of course, here. So there's a considerable expense and challenge in operation. This isn't a star analyzer image, but that's really exciting. Very cool.
But it's this is the actual ring nebula spectrum. That's an integrated one across the whole width of the nebula.
Neat. Cool.
So we've got a couple of little sulfur peaks here.
Mm-hmm. What do you think those?
Argon up here.
Mm-hmm. Oh, okay.
So that's argon. Those two are sulfur.
Right. Do you have much interaction with the BAA in the spectroscopic world, Steve? Go ahead.
Not really. I'm about to get into it. In that respect, most of the stuff I do is just for my own interest at the moment.
Neat. Cool. Well, great. Thank you so much for sharing that. That's interesting. I think probably a lot of us enjoy seeing that.
Are you talking about Robin Ledbetter?
I know Robin, yes.
Yeah.
Any other projects people are working on or questions? Again, the risk here is that people go away like me and go, God, these people really know what the flock they're doing. You know, I can't hold a candle to these people. You know, Conrad's laughing because he knows it's true. And,
I've been doing this for over 9 years. So it's not the kind of thing you learn about in one evening. You know, I've tried a lot of things over the years. I just started out with a star analyzer and a basic configuration. And then just, as time goes on, try different configurations. I had a lot of failures in the process, but eventually came up with something that getting me into higher resolution, which all of a sudden just brings out a whole new area of astronomy that I just couldn't get to before, and is much more interesting.
What are you using, Conrad?
I have a 3-inch f6 apochromatic refractor. If I share my screen, I can just show you a little something.
Please.
All right, here we go.
Take all the time you want. These are your people, you know.
Okay.
Revel in it.
Let's see. All right, this is a photo of the 2-inch square diffraction grating that I have. I bought it from Edmund Scientific. I had to build a little filter holder for it.
Mm-hmm.
Put it in front of the achromat or I should say the apochromatic lens that I'm using. And consequently, I have a camera at the end of it. I have a ZWO camera.
Mm-hmm.
And as a consequence, I'm getting very high resolution photos. This is Beta Canis Minor. The dispersion is like 0.36. It's really high, but all of a sudden, there's a lot of detail in here that I was never able to get just using the old-fashioned converging lens. And so you see a lot more.
So this is an objective grating in front of the lens of your telescope, correct?
Yeah, that's right.
Now
you could actually do this with the star analyzer.
Yeah.
This is a 3rd magnitude star. You could do it with a star analyzer in front and get some pretty good resolution with it.
Mm-hmm.
Conrad,
yes.
I will fess up to what I've been doing of late. I'm working with a manufacturer on a 100mm grating, front-end grating, with a high efficiency, single first order emissions and blaze to 550 nanometer. In discussions right now, and it's something that I hope to bring out as a product eventually in the next year or so. So hold on.
Yeah. Oh, yeah.
How many lines per inch is that grating?
Well, I'm looking at around 200 because I'm looking at focusing, short achromatic refractors, 400, 500 millimeter long, to be able to fit into a full format CCD lens, and it'll give the angstrom to pixels of around 0.5.
Okay. How many are yours?
Oh, well, hopefully we'll be seeing something this year.
No,
and the R values are extraordinary. They're in the multi-thousand, which is quite scary.
Conrad, what did you get from Edmund? How many lines per inch?
This one is 300 lines per millimeter.
Per millimeter?
Well, yeah.
It was only a couple $100, and it wasn't that expensive. And just
300 lines per millimeter.
There's a lot of beta emission stars in M45. This one is Electra, and this is an absorption line, and in the center of it, you get some emission lines as part of it. This is the hydrogen alpha line. There's a lot going on in these stars. Some of the outer layers of the stars are kind of expanding outwards. So in addition to the absorption line, you get a little bit of emission line in there too.
What's the explanation of that? I don't know the astrophysics behind that. Does anybody?
I'm not quite sure. When you get both emission and absorption lines at the same time, and that's where a lot of research is going into.
Yeah.
If you look at some of the European sites, they're doing a lot on an amateur level in these areas.
Mm-hmm.
One more to look at. This is New Gemini. This is a 4th magnitude. The limit that I can do with my setup is between 4.5 and 5 magnitudes. But here's an example where I get a hydrogen alpha emission line, but then in the center of it, there's an absorption feature in there. And some of this is a result of rotating B stars.
Yeah.
Which give you some of this absorption feature amongst the emission features. It's just really weird stuff. But I'm sending all of this to the AAVSO for their website, and other people are downloading this data to look at it.
Oh,
So
that's
it's
cool.
not like you're just sending it for nothing.
So does Stella review every spectra that you submit? Do you get feedback from her, or things just?
No, I don't get any feedback, but she reviews it in order to verify that it is meaningful data and not just a bunch of junk.
Very cool.
Not just a bunch of artifacts in there.
Well, and that you mentioned a moment ago, I think it's a good for people to recognize, and that is with this much dispersion, with things spread out so much. I mean, here's an example, and I mentioned it earlier. You don't have a zero order to calibrate on, but in this case, it's pretty clear you've got some features with which to calibrate. But the other thing is, with that much dispersion, you have a lot more noise, and exposure times go way up in order to capture. So you said your limit is about mag 4 with your 3.
But actually between mag 4.5 to 5.
Okay.
Overhead, I can go up to 5th magnitude. If it's closer to the horizon, maybe 4.5 magnitude.
Is that stacked or just single shot?
That's at the max.
Is that a stacked image, or are you?
Oh yeah, these are all stacked. Like for example, each one of these images, okay, this is 40 images that have been stacked. Each image is about 15 seconds.
Okay.
And I'm using AstroArt to stack all my images. And
how does that handle spectra when there's no zero order involved? Or is it able to? Go ahead.
Well, there's no problem at all, because I find it very easy to discover these emission lines. And then on top of it, the angstrom per pixels is very constant.
Uh-huh.
So at this rate now, this is just a cutoff
Mm-hmm.
of the whole spectrum that I have. But it becomes, and I can always use this 0.367. It's very easy to find the hydrogen alpha line.
Right.
And once I set it that way, if there's any other lines in there like this helium line, there's no problem identifying it.
What kind of mount are you using, Conrad?
I have a Celestron AVX mount.
Okay, it's doing pretty well for you.
Quite a few years. It's a go-to mount.
Yeah.
They've got some good software with it, and all of my stars are dead center. Whenever everything is properly aligned, when the polar alignment is right, everything else works out really well.
Can you see these stars in a single image, or do you have to stack them to see them?
I've got to stack it.
So you're shooting blind, basically.
Well, I could pick the star out. Okay, finding the star in the center of the camera is no problem.
Good.
I have to scroll to the left, and then I will see the spectra come up, and I'm getting to the point where I have no problem identifying the emission line.
So you can actually see the spectrum in a single image or visually?
Yes, I can see it visually, and actually I count so many seconds. And when I scroll over to the left, then I know, well, in my situation, it's about 10 seconds, 9 to 10 seconds. I have the hydrogen alpha line right in the middle.
Wow. Very cool.
Oh yeah, these are neat features to start seeing. When you first start off with RSpec, you get a couple big blobs. You get the hydrogen alpha, the hydrogen beta, hydrogen gamma. And then after a while, you get tired of looking at that, and you just go to higher resolution to see all the real good stuff. But it took me years to get to this point. But it was well worth it. No doubt at all. It was well worth it. No regrets at all.
Well, that's nice to hear. Well, where are you located again?
I'm in Rhode Island, a little town called Hope Valley. It's a nice area. I've got a nice little observatory outside my house.
And you get enough clear skies so you can do this kind of observing in New England, huh?
Oh yeah, I can. No problem. I'm in a darker site in Rhode Island. There's no big cities nearby.
Nice. Very cool.
Oh yeah.
Thanks for sharing all this. That's
okay. You're welcome.
Great. Yeah, and I hope as you learn more about the nature of those features, I'd love you to drop me an email or post something on the forum where we can learn a little bit more. I mean, because as all of you know, I'm more of a software guy than an astrophysicist or an observer. So I'm always learning from all of you.
Yeah.
Anything else people have to contribute? Well, listen, thank you all for joining us. We've lost some people, and that's understandable. Keep in touch. Tim, thanks for your help today. And Rick, nice to see you. David, you and I have some talking to do at some point. And John from New Zealand, thanks for coming up or signing in. It really is a flat world now. And the rest, everybody else, I'm looking at you, even though you can't see me looking at your particular stamp. Thanks again for joining us.